Cool. All right. So just to recap what we've been, or sorry, where we are right now, you guys have done part A. So we've understood why we need to dilute our original solution. And now we're moving on to part B and part C. I'm going to teach part B and C together because the calculations for both of these are very similar and they're both talking about the titration process. Before I go into the actual question itself, I just want to point out what the Achieve, Merit, and Excellence criteria are, just so you guys kind of are aware of what we're doing. And like I said, Part B and C are combined together as well when it comes into the marking schedule. So some things to kind of keep in mind is that basically you have two chances for the merit. If you do the calculation correctly for Part B or Part C, that is enough for merit. So basically that allows you to make one mistake on it allows you to make a mistake on Part B or Part C and you can still get merit overall. If you are aiming for excellence, however, you need to pass both Part B and Part C perfectly. So just kind of keep that in mind when you guys are working. There's some other nitty-gritty details that I'll point out as I'm going through it, but I just wanted to point out that that is kind of the way this is structured, is that you get that two chances with your calculation for merit. Some other things to kind of keep in mind is for the achieved, it's basically you've done the merit, but maybe you've made a mistake. And so long as you can show like one aspect of the process, you'll be able to get your achieved for that. So I'll go ahead and start the question so you guys can kind of see what it looks like. I want to hopefully ideally get Part B and Part C I want to teach Part B today, and I want you guys to start collecting data for Part C today, hopefully if we have time. If not, that'll be Thursday's lesson. But like I said, I want to try to teach it together because they're very similar. And then we'll see how you guys feel on Thursday and how we want to spend basically the last week of term, if you want to assess anything or if you want to hold off till next term. So we're definitely not going to finish this assessment this term. Just FYI, we will carry it on to term 3. But I am mindful that you guys might want to assess Part B before we go on break. So that way you have basically half this assessment done. So it's really, we'll see how you guys feel and what you guys want to do for next week. I don't think there's time to get Part C assessed. I think you guys will probably need some more time with the equipment before you feel confident in doing that. And I don't think I'm going away. I don't think I am going away for the holidays, so we can also schedule some tutorials during that break time as well. So just keep that in mind, and let's put the phones away. Bye-bye. All right, cool. Let me then show you what we're thinking about for Part B. So some things I just want to kind of give you guys a note of. Part B is very similar to Part C in the fact that you are collecting titration data and we are using it to calculate concentration. The difference between Part B and Part C is that Part B is designed just to confirm the sodium hydroxide concentration. So just as a note, for Part A, and I think I'll put Part A lying around, show you what we're doing. Yeah. Okay. So Part A, if you guys remember, we were testing to see the concentration of lactic acid in our sour cream. And this was this equation here. Okay. Now, before I can jump into this titration, what I want to do to make sure I have really good results is I want to confirm that my NaOH is the right concentration. So Part B is confirming that the NaOH is 0.1 moles per liter as claimed. So that is the reasoning to what we're doing for Part B. So I'm just trying to double check my concentration for Part B to make sure it is correct. So that way when I use it in Part C, I know it is the right concentration. Okay? So just basically like double checking it. So in order for me to double check it, I'm going to do another titration. Now, in this case, we are giving you the titration data, so you don't have to worry about doing this titration and collecting data. The other reason why we are doing this is because for the excellence, you need one version of the equation that is not a 1-to-1 ratio. So let me show you what I mean by 1-to-1 versus not 1-to-1. So in the titration you guys will be doing, for every 1 lactic acid that you have, it is neutralized by 1 sodium hydroxide. So that is a 1-to-1 ratio. Okay? In this assessment guideline, you are not able to get excellence if you just have a 1-to-1 ratio because that's too easy calculation-wise. So we need to give you at least one equation that is not 1-to-1, which is why we're doing this part B, because in this equation here, what you'll notice is that this is a 1-to-2 ratio. 1-to-2. So for every 1 sulfuric acid, I will need 2 sodium hydroxides, is what that's referring to. So I need to have one non-1-to-1 ratio in order to be able to award you guys excellence. If I didn't stick this in here, then you would only be able to get maximum merit on this assessment. So that's why we are doing that. The other reason, like I said, is to confirm that we know that the sodium hydroxide concentration is 0.1 like claimed. So sodium hydroxide cannot be used accurately as a primary standard against your investigation. We need to standardize it. So we're just checking to make sure that it is a 0.1 concentration. Are we okay with that so far? All right, cool. So next thing I'm going to do is I'm going to double check to see and go through the steps on how I can double check my sodium hydroxide concentration. And this is why I wanted you guys to do those SciPad pages here, because these tie into part B and part C. So I will reference this as I'm going through this, just to make sure you guys know what they're talking about. So first thing that I do, what I'm trying to do this standardization is that I want to make sure that I prepare my sulfuric acid. When I prepare this sulfuric acid, what I have done is I have taken 1.79 grams of my sulfuric acid. I should probably do that in, I'll do this in orange because that's showing you processing. And I weighed it on a laboratory balance, and what I did was I made, added 250 mils of water and shook it until it was fully dissolved. So this here is my mass, if I'm curious, mass. This here is my volume. So basically, I want to figure out what concentration of sulfuric acid I've made. Now, something to keep in mind is that we can look at units in 2 different ways. We can look at things as in grams, and we can look at things as in moles. When we talk about grams, we are talking about the mass of what I am dealing with. So that is basically, you go on the scale, you weigh it out. So like if you hop on a bathroom scale, that's the same thing. You're trying to figure out your mass. That is actually not useful to us in a chemistry stance because mass just talks about weight, whereas moles talk about actual quantity. So I just want to show you guys the notes that we had for the SciPad. So mole is just referring to another form of unit. It's basically a way for us to determine how many particles we have there, which is then useful for when we're looking at equations. The thing that we have to keep in mind is that atoms have different sizes. So carbon, for example, has a mass of 12, whereas hydrogen, on the other hand, has a mass of 1 of its atom. So let me kind of give you guys some notes for that as a big quick crash course. Grab some paper. All right. So if I was to draw the carbon atom, there goes all my markers. So if you looked at carbon on the periodic table, you see that it would be labeled C. It would have a 6 in the corner. That is the atomic number. Atomic number is referring to what from memory? Come on, level 2 chemists. Don't remember? So 6 is referring to the number of protons. It also refers to the number of electrons. Remember, protons are positively charged, electrons are negatively charged. So what that's telling me by that 6 is that I have 6 protons for that carbon. I also have 6 electrons for that carbon. Okay? Now, things to keep in mind, atoms can gain or lose electrons to form ions, and it's still the same element. Whereas if you gain or lose protons, you have changed the element, because that is unique to the element there. All right? The other thing that you see on the periodic table is the bigger number, which is our atomic mass. And that's talking about how big that atom is. So in this case, with the number 12, it tells me that I have 6 protons plus 6 neutrons, because that's how I add up to 12. Basically, I just did 12, I subtracted 6 to figure out my neutron number. So this is my mass. This tells me how big and how heavy my atom is. Are we good so far? All right, if I looked at another atom on the periodic table, say, for example, hydrogen, because it's a nice tiny atom, it has an atomic number of 1, and its atomic mass number is also 1. So what that tells me when I'm looking at this is that it only has 1 proton. Now, if I was trying to compare carbon to hydrogen and I was just weighing it as 1 gram, 1 gram of carbon means something very different from 1 gram of hydrogen because they are not the same size. It's like, for example, if you were trying to determine the number of people in a room. Let's say you had 1,000 kilograms of people in the room. Now, 1,000 kilograms of adults, kilogram-wise, could be a different number than 1,000 children in kilograms. Does that translate? So we're talking about different size things. So in order to make things uniformed, and that way we can compare apples to apples, we use a unit called the mole, which is this guy here, mole. So this is actually talking about quantity. So if I convert from mass to moles, I now can compare and say I have 5 humans and 5 children. Whereas if I was trying to compare 5 children and 5 adults by mass, it would be 2 very different numbers. Are you okay with that so far? All right. So that is what we're doing when we are doing these calculations. So we need to convert this from a grams to a mole. Now, one of the things you have to keep in mind is that our equipment isn't designed to measure things based on moles, which is very logical because every single compound you're dealing with or chemical you're dealing with is going to have a different mole ratio. So if I wanted to sit there and count individual atoms, that would also be very inefficient as well. So we use the scale because the scale is easy. We just dump things on there. Then we have to mathematically translate that into moles. Okay? That's the most efficient way for us to do it instead of, counting atoms or having to plug into the machine every time the mass of what we're using for it to do the calculation for us. So we do it just for simplicity's sake. Now, in order to do this conversion, what we need to do is this equation here. So N is referring to the amount, which is in moles. The little m is referring to mass, which is in grams. And then the big M is referring to molecular mass. That's actually looking at the atomic weight on the periodic table and giving us a ratio. So that is referred to as grams per mole. So basically, what would the weight be if I had 1 mole of that substance? Any questions so far about that? Are we good? All right, so let's start plugging in the numbers. So in this case, something to keep in mind is that we calculate out the molecular mass for you. We give you the big M. If I didn't give that to you, what you would do is you would look at the periodic table and you would look for each one of those elements and add them together. Let me pull the SciPad questions to show you what I mean. So here we go. For example, you see how we had methane, which is C with 4 hydrogens. If I wanted to figure out the mass for that, I would look up the mass for carbon, which is 12, plus the mass of the hydrogen. So the hydrogen is 1. Now, since I have 4 of them, that means I have 4 times 1. So then I get a total number of 16. So that's how we find those numbers there. Questions, concerns, comments about that so far? Do you need me to do another one? Yeah. All right. I'm just trying to see ones that I like. Do I have silicon? Do they give me the mass of silicon? I give me the mass of silicon, but the other one you to do the calculation. That's nice. All right, I'll do silicon dioxide because that's also a mixture of stuff. So silicon, I'm just going to look up the atomic mass real quick for that one. Mass, not pass. All right, so it's 28. So I have one silicon, that's 28, plus my oxygen. Now oxygen is 16 as its atomic mass. But since I have two oxygens, I need to multiply that by 2. And then if I add that all together, let me get my calculator. So I have 28 plus 16 times 2. I like to use the brackets just in case, so that way I make sure the order of operations is correct. Press enter, and so the mass of that is 60. Or sorry, the molecular mass of that, 60 grams per mole. So basically, I don't need to do it because I have the divide sign. So basically what that means is if I want 1 mole of silicon dioxide, I would need to weigh out 60 grams. If I weighed out 60 grams, I have 1 mole. If I weighed out 120 grams, I have 2 moles. Are we okay with that, or do you need to see that again? Are we okay? Okay. So for this question here, I want to figure out the number of moles of sulfuric acid I have based off of what I've weighed out. So I have weighed out a mass of 1.79 grams, and I need to divide that by the molecular mass, so that way I can figure out moles. So the molecular mass is 170.08 grams per mole. Oops, 170, 0.08 grams per mole. Now, I personally like to write the units down because it's a really good way for me to idiot check myself to make sure I have arranged my equation properly. Basically, what I should have is my units should cancel out and I should get the unit that I need for the answer. So when I look at this, grams and grams will cancel out and I have per mole. We see that the per mole is below the division sign, so that converts it back to mole, which is what I want because I want to figure out the amount of sulfuric acid. So 1.79 divided by 170.08, and I get 0.0105, and then lots of different numbers there. Leave your numbers long, round at the very end. So 0.010524459, and then that's in moles now. Are we okay with that so far? All right, if you are not confident with that calculation, just be mindful that this is on the SciPad pages. You see how in this case they've given you mass and they want you to figure out how much you have mole-wise if you had a mass of carbon. And then this one over here, you're doing the same thing. If you have this element and you have this amount, then what is the mass going to be on the scale? So if you need to practice those are on the SciPad pages. All right, cool. The next thing I need to now figure out is concentration, which is shown by this equation here. So concentration is equal to the mole amount divided by the volume. And we've figured out the volume up here. So if I was to plug in my numbers, I take my answer from question 1, which it says take the answer from question 1, 0.010524459 moles, and divide it by the volume. Now, something to keep in mind with the volume is that we need to have volume in liters. Now, I have given this value in milliliters, so I need to divide by 1,000 because it's 1,000 milliliters in 1 liter. So that would be 0.20 liters. And now I can get a value that's in moles per liter, which is the concentration. I don't clear my calculator between takes, so that way I can easily take my answer and just divide it. So the concentration of the solution is 0.042, lots of numbers, moles per liter. Again, I don't round to the very end. I'm basically looking to see if it says you need to round it. So that's telling me my concentration. Questions, concerns, comments so far? Or is this okay? Are you okay? All right. Just watching our time. See how long I'm recording for. 20 minutes. Ooh. I should give you guys breaks in. Okay. Actually, do you guys want to try doing number 3 now that you've seen how to use the equation? So this equation here is concentration. Now you need to rearrange it for N. You see right here, we're trying to figure out if I take an aliquot of my sulfuric acid, which I know the concentration of, how many particles of sulfuric acid do you have is the question. So you're taking a 25 ml sample of the sulfuric acid. You know what the concentration is. What is your N? So I'll give you guys a little bit of a break. Try to figure out what N is. Rearrange that equation.